Have you ever found yourself just, stuck in that maze of traditional medical systems,
Oh, yeah?
waiting forever for an appointment maybe? Or if you're managing something chronic, just wishing for support that's, well, there when you need it?
It's a huge frustration. And it's getting tougher, isn't it, with the aging population, more chronic conditions.
Exactly. The systems feel stretched, slow. You can't always get timely care.
Mm-hmm.
I mean, think about this statistic. It blew my mind. In Canada, back in 2017, the average wait just to consult a specialist was over 21 weeks.
Wow.
That's almost 5 months, just waiting in line.
5 months, yeah. You could pick up a new hobby in that time.
Right. Okay, so let's unpack this, because today's deep dive is really about how technology is trying to tackle these massive healthcare challenges.
And our mission really is to look at this proposed solution that brings together two really powerful technologies: wireless body area networks, WBANS, and blockchain. We want to explore how they can create something more efficient, more economical, and crucially secure. A sort of 247 eHealtheare system. And what that means for you, for your health monitoring and your privacy.
And that privacy part is huge. There's clearly this massive demand for a system that's, well, always on, efficient, secure, something that can watch over your health, keep your data safe, and give feedback.
Yeah, and that's exactly where eHealtheare systems come in. They're really gaining ground thanks to all the advances in tiny biomedical sensors, the Internet of Things, modern communication tech. It's all converging.
Right.
And fundamentally, these eHealtheare systems aim for what's called the triple aim.
A triple aim.
Yeah, it's about improving your individual experience of care, improving the health of whole populations, and this is key, reducing those per capita costs.
Which are just skyrocketing.
Exactly. And these systems, they can support everything remotely. Prevention, diagnosis, treatment, follow-up, the whole spectrum.
Okay, so that's the promise. A better, smarter, more accessible system. But how do we actually build it? Let's get into the tech. Starting with wireless body area networks, WBANS. Why them?
Right. So eHealtheare involves, different kinds of communication. There's the big network stuff, like the internet. But then there's the really close-in network, literally like around your skin surface, connecting sensors on your body to some kind of central device. Now you might think, oh, Bluetooth or Zigbee?
Yeah, those are common.
They are, but they weren't really designed for this, for continuous medical monitoring. They have drawbacks. The frequency, the data rate, how much power they use, the security. It's not quite right.
So WBANs are different. They're purpose-built.
Exactly. It's a specific standard, IEEE 802.15.6. Came out in 2012, designed purely for transmitting data between biomedical sensors and a device close to the body.
And what makes them better for this job?
Well, the big one is power consumption. They're way more sensitive to power needs. We're talking maybe 0.1 milliwatts up to less than 10.
Which means
your sensors could potentially run for weeks, maybe even months, on one charge.
Wow, compared to Bluetooth.
Which is more like 10 to 100 milliwatts. You'd only get days of usage, typically. That's a massive difference for something you might wear constantly.
Huge difference, okay.
Plus, for the kind of simple data, these sensors often collect heart rate, temperature, stuff like that. WBANs have lower needs for frequency, data rate, bandwidth, and they have their own lightweight security built in. Authentication, encryption, specifically for WBANs.
Okay, so that low power, dedicated security, that sounds like a really solid foundation for the on-body part of the system. Let's switch gears then. Blockchain, that's the second piece. What's fascinating here, you mentioned, is trust and decentralization. No central boss.
That's the core idea. Blockchain provides trust in transactions within a system where there's no single authority overseeing everything.
How does it do that in a healthcare context?
Well, think about its key features. Every change, every piece of data added is logged permanently. It's immutable. You can't go back and secretly change it.
Right, like a permanent record book.
Exactly. And every transaction is signed with a private key.
Yeah.
So you have non-repudiation.
Yeah.
You know who added what.
Right.
And they can't deny it later.
Okay.
And then there's privacy, managed through strict access control rules. Who gets to see what data? This is absolutely vital with sensitive health information.
You don't want just anyone seeing that.
Definitely not. And think about the problems in traditional systems. Getting different parts to talk to each other. Doctors, pharmacies, insurance, emergency services. It can be a nightmare. Interoperability is a huge challenge.
Siloed data.
Precisely.
Yeah.
Blockchain can help break down those silos. Imagine electronic health records, EHRs, on a blockchain.
Yeah.
You've got sensors tracking loads of data for personalized medicine.
Hmm.
Heart rhythm, glucose levels, did you take your meds?
Okay.
Blockchain offers a way to securely and reliably exchange prescriptions, medication records, sensor readings between everyone who needs access, ensuring the data is trustworthy, no mix-ups, no faulty data messing things up.
So we have WBANS, great for collecting the data right from the body super efficiently, and blockchain, great for storing and sharing that data securely and reliably without needing one central database.
Yep.
The big question then, how do they actually work together? Do they integrate seamlessly?
That's the beauty of the proposed system. It's designed for them to interoperate. WBANs are the front end connecting the sensors. Blockchain is the back end handling the secure data storage and transmission across the wider network.
So they have distinct roles.
Very distinct. They're almost orthogonal. WBAN secures the local communication on the body. Blockchain secures the data after it leaves the body when it's stored and shared. They work together to tackle the different security challenges in an eHealtheare system.
Okay, but you mentioned the sensors are tiny, low power.
Right, resource constrained.
They can't run blockchain calculations, surely. That takes serious computing power.
No, they absolutely cannot. And that's a key architectural choice. The sensor nodes just collect and send data. That data gets aggregated first, probably in what's called a WBAN hub, or a centralized device.
Like my smartphone.
Exactly like your smartphone, or maybe a small dedicated gateway device. That hub does have more power. It gathers the data from the sensors, and then it transmits it securely to the blockchain backend.
How securely?
Using things like a secured REST API, probably with transport layer security, TLS. Think of it like the encryption that protects your online banking connection.
Right.
Robust standard security between the hub and the blockchain network.
Ah, okay. That makes sense. You separate the tasks based on capability. The sensors do the sensing, the hub does the handoff, and the blockchain does the secure ledger part.
Precisely. It's an elegant way to leverage the strengths of both technologies.
So let's summarize the big wins here. What are the standout advantages when you put WBANs and blockchain together like this?
Well, first, you get that ultra-low power consumption for the part you're actually wearing, which is huge for usability, weeks or months of battery life.
Right. Huge.
Second, the data itself becomes inherently trustworthy because of the blockchain. You know it hasn't been messed with since it was recorded.
That immutability thing.
Exactly. Third, decentralization. The computation, the storage, it's spread out. No single point of failure. Much more resilience. And finally, those blockchain properties, immutability, non-repudiation, give you incredibly powerful tamper-proof logging and auditing, essential for healthcare records.
Okay, that sounds pretty compelling. But, nothing's perfect.
Yeah.
What about the downsides? Blockchain can be power hungry for the computers running it, right? And getting different blockchain platforms to work together isn't always easy.
You're absolutely right. Those are known challenges with blockchain tech itself. High compute resources, energy use at each node, potential incompatibilities between, say, Hyperledger and Ethereum platforms.
So how does this WBAN blockchain system deal with that?
That's where the architecture really shines. By separating the front end, the low-power WBAN, from the back end, the potentially resource-intensive blockchain, it shields the sensors from those demands. The heavy lifting happens off-body on machines that can handle it.
So the patient doesn't experience the blockchain's energy needs directly.
Correct. And regarding compatibility, while it's a broader blockchain issue, designing the system with standardized interfaces, like that secure REST API we mentioned, helps manage how data gets into the chosen blockchain platform. Now, this specific system, when they evaluated it, they used a platform called MiniB, a smartphone, PCs.
Okay.
And the results were really promising. Low hardware use on the user end, strong security, stable performance. It showed the concept works in practice.
And it seems the motivation here was really filling a gap. Previous work hadn't quite meshed WBAN security with blockchain security in this way.
Yeah, that seems to be the case. A lot of the healthcare security work existed, but creating this secure, compatible, and really meaningful link between the two for a blockchain-based system was the novel contribution here. It's a definite step forward.
So, wrapping up the core discussion, what we've really explored is a pathway to a healthcare solution that's both secure and low power. It seems to have, genuinely great potential for modern medical systems.
Absolutely. And, it really raises an important question as we look forward. With these advances in remote monitoring, coupled with this level of data security and trust, what new possibilities open up? Things we haven't even fully imagined yet for personalized health or even big public health programs.
That's a fascinating thought to leave with. And for you listening, maybe think about how this blend sensors on your body, talking securely to the distributed ledger, could change your future interactions with healthcare. From just a routine checkup, maybe, to managing a long-term condition, all potentially with much greater security, accessibility, and maybe even peace of mind.